Hello, Professor. My name is Hieu, and this is my project about using sugar as preservative. So, how can sugar preserve food? Sugar can form a weak bond with water so that it will absorb water on the surface of the food. And secondly, the high concentration of sugar outside of the fruit, it will create a hypotonic osmosis so that water will be drained out from also inside of the fruit. Therefore, without water, microorganisms cannot reproduce. And based on this theory, we believe that the higher the concentration, the better sugar will preserve food. There are two objectives for the experiment. The first one is we want to analyze the effectiveness of sugar as a preservative. And the second one is we want to determine the other factor that can also contribute to prolong the shelf life of food. For example, pH. However, because this is the home-based experiment, we don't have the lab setup, so contamination is likely to happen. However, we will try to minimize it. So for the experiment, we choose raspberry as our sample. We have sugar, container for sugar solution, balance, petri dishes, spreader, pipette, sterile bag, gelatin powder, and extract. To determine the effectiveness of sugar, we will compare between the fruit that is sprayed with sugar solution and the fruit that is not. There are two categories for comparing, appearance chains and microbial chains. So in appearance chains, we will compare the color, the texture, the smell, and the formation of mold on the fruit. And for the microbial chains, we perform spray plates on the homemade agar. 3 sugar solution concentration are 10, 30, and 40%. Since I also want to analyze the effect of pH, so I also add the vinegar into sugar solution to bring the pH to 3.5. So in total, I have 6 bags for the sample and 2 bags for the control. And I name the sample as this table. So C1 and C2 are the control, and S1 and S2 are treated with 10% of sugar solution with and without vinegar. So this is the summary of my step. So first, we're making the sugar solution and the home-based agar, and afterwards, I will spray the sugar solution on the fruit and also inoculate 0.1 gram of fruit onto the home-based agar. And afterward, I will record the appearance change, and also after 3 days, I will observe the microbial change on the home-based agar. I have some pictures of my results for the appearance change. So in the first row is when I bought the fruit, and the second row is the last day of the experiment. So this table summary of my result from the first to the last day of the experiment, and I use the scale system to evaluate the appearance change. So 5 points indicate that the fruit is in the good condition and one is very bad condition. However, this result has variation since it depends on the observed person, which is me and my lab partner. So from the table, we can see that the appearance for C1 and C2 deteriorate the most, while for the remaining samples, there were not much difference in the appearance change. I have the pictures of the growth after 3 days, incubate them in the room temperature. So all the growth are thoroughly, meaning they are the same. And I will summarize the result for in the next slide. So this is the result for microbial chains. There are no growth in the control plate, meaning the still water is sterile. The appearance of worm colonies in every place are the same. It means that there are no contamination from the outside source. Sample C1 and C2, which are the control, has equal amount of growth, meaning that the media that I use in this experiment do not promote the growth. Sample C1 and C2 also has the most growth since they are not treated with sugar solution, while sample S5 and S6, which are treated with 40% of sugar solution, showing no growth at all. And reminding that sample S1 and S2 are treated with the same sugar concentration, and sample S3 and S4 also treated with the same sugar concentration. However, the growth of sample S2 is less than sample S1, and sample S4 is less than sample S3. So it means that pH also contributes to prevent microbial growth. And however, there is one variation in this experiment, and that is the growth of sample S3 and S4 more than sample S1 and S2, which is unexpected. So the experiment has proven that sugar preserves the appearance of fruit, since appearance of the sample C1 deteriorate the most compared to other samples. Um, So our theory has stated that the higher the sugar concentration, the better it will preserve food. It shows in the result of microbial growth that 40% of sugar solution showing no growth at all, while 10 and 30% have less amount of growth compared to the fruit that were not applied with sugar solution. Besides, pH also contribute to prevent the growth. There is one unexpected result, since according to the theory, high concentration of sugar preserve food longer than low concentration. However, the place of 30% of sugar solution has more growth than 10% of sugar solution. So I think that it might be because of the contamination from the inside source, meaning from the other bags. It might be contaminated from the low sugar concentration, or it may be because of the techniques of the performers that we might not transfer the exact 0.1 gram. I have three conclusions. So firstly, sugar solution preserve and prolong the shelf life of fruit. And secondly, sugar solution at pH 3.5 preserve fruit better than sugar alone. And thirdly, 40% of sugar solution is preferred for preserving food.